Hello students, I am Bhumica Verma, Assistant Professor in CSE Department in Ajay Kumar Engineering College. And today my lectures aim about the applications of artificial intelligence. So basically these are the application of AI that I'm going to discuss one by one. So this is the topic that is covered in the unit 5 as per the AKTU syllabus. So the applications of AI includes game playing, medical diagnosis, autonomous control, autonomous planning and scheduling, expert systems, robotics, NLPs, natural understanding and problem solving, machine translations, computer vision, e-commerce, and heuristic classification as well. So I'm going to take one by one to discuss all this. So first is the game playing. Game playing is none other than the gaming bot that are introduced or developed who will play with you, such as you have used in the form of checkers, chess, or eight puzzle problem or 15 puzzle problem. So the first computer program that is introduced is the IBM Deep Blue. That is a computer program that defeat the world champion in the chess match, and whose score is score of 3.5 to 2. And to beat this world championship, the IBM brute force, the IBM Blue uses the brute force techniques, which is well known as the reliable heuristic, requires being able to look at the uh, uh, at 200 million positions per second. So basically it uses the brute force techniques, and as per the efficiency of that IBM Blue, it can think, it can view up to about 200 million position per second. So these are the first application. This is the basic application that is used in the AI, that is being used in the game playing. The second is the medical diagnosis. Medical diagnosis, in this, the medical science AI is used to create a virtual personal health care assistant. In this, the medical clinic can use AI to organize bed schedules, or it can make the staff rotations. It can also provide the medical information and other important tasks. The major application in this field are cardiologies, neurologies, and also sonographies, and many more complex operations of the internal organs, etc. The first expert system used in the field of medical diagnosis is the mycin, that is used to diagnose bacterial infections of blood and suggested treatments. So third is the autonomous control. Autonomous control is the field that enables the scientists and the engineers to create the autonomous technologies that can function on their own while adapting in responses to the changing environment and scenarios. As per the situation here, this machine is being controlled by the system, where no driver is being sitting, and this system is this car is being drove by a system that is coast to coast under some computer control. For sure, this is up to a certain range of 50 to 3000 miles up as well. So basically, when I am analyzing the autonomous vehicle, because as this is the emerging field of the applications of AI, that is autonomous vehicles, autonomic systems. So here the autonomous vehicle segment is the fastest growing segment in the automotive industries, in which it provides a sophisticated components of self-driving vehicles. In this, a kind of perception and sensing is being done. As you can see that the automated connected vehicles is having some kind of GPS, wheel encoders, onboard unit, ultrasonic sensors, radar, lidar, and cameras, etc. So in that form, it can able the AI software in the car is connected to all the sensors and collect input from the Google Street View and video cameras inside the car. And in this way, AI can able to stimulate the human perceptions as well as decision making, using that kind of deep learning strategies and control action in the driver control system. So in this case, the perception and sensing is being done, and autonomous vehicles heavily rely on some kind of AI algorithm to process vast amount of sensors data. For instance, if I'm talking about a single autonomous car, it can able to generate 4 terabytes of data per day. Okay, and capturing information from the cameras, lidar, radar, and ultrasonic sensors. In this way, all the information from these components are being censored and being collected and captured, as well as together they are integrated to provide a control over that autonomous vehicle. So this is one of the application of AI. Fourth is the autonomous planning and scheduling. It is also denoted as a branch of AI that concern with the realization of strategies of some action sequences, or typically for the execution by some kind of intelligent agents or autonomous robots or any unmanned vehicle. That means these are the autonomous planning in which the absence of man is there, and all the strategies, all the action sequences is done by the system itself. So it is basically used to optimize the resources as well as to save the time. It is also helpful to improve the decision making and the coordination among the team members. The one of the example of autonomous planning and scheduling is the basically the telescope scheduling, which is recently done in the Vigyan rover that is being launched. So this is one of the application of AI. Fifth is the expert system. So expert system, as the name suggests, is a computer program that is designed to solve some kind of complex problem, or it is able to provide some kind of decision making ability like the human experts. In this, it performs like by extracting some knowledge from the knowledge base using some kind of reasoning or inference rule according to the user queries. So as per the picture says here, a normal person is being sitting, that is being a non-expert user, and here some kind of knowledge is being given by the experts. So here this expert indulge this knowledge into some kind of knowledge base. So this knowledge base is nothing else but the collection of various kind of knowledges from various kind of sources or domains, or you can say some kind of corpus that is being embedded into that knowledge base. So the efficiency of this expert system totally depend upon the size or the variety of the data or the knowledge in the knowledge base. And finally, this knowledge is being inferred in the form of rules or engines. So here the inference engine is being used. Inference engine is basically the engine which uses the knowledge of the knowledge base as per the user requirement. These are of two types that we have studied earlier, that is of forward chaining, and the second is backward chaining. So this is the way how this inference engine work. So as per the knowledge being derived into the inference engine, some rules are being decided here, and this engine works as per the rules, and according to the forward or the backward chaining, it gives that rules or some output back to the user. So whenever a sample input is being given by the user in the form of user interface, it is being directed to the inference engine, and finally after recommending all the knowledge base, it is further move on or revert back to the user in the form of any advice. So basically it solves the complex issues as per the expert by extracting the knowledge stored in the knowledge base. So it uses both, as the knowledge base is here, it uses both the facts or the heuristic like the human experts. It is called so because it contains the expert knowledge of some specific domain and can solve any complex problem of that particular domain. So these systems are basically designed for any kind of specific domain in the form of or in the field of basically medicine or sciences. The performance of the expert system, as I've told you, that it is depending upon the knowledge base, and it is based on the expert knowledge that is stored in the knowledge base. So as the knowledge in the knowledge base is more or more efficient, you can say more the system efficiency is high, or system performance is very high at that time. So the common example of the expert system is the suggestion of spelling errors while typing in the Google search box is one of the examples. Some other examples of expert system is Mycin, that I have already told you in the previous slides. That is, it is the expert system that is used to give the suggestions about the bacterial infections. Some more examples are Dendrils, PixDS, and Cadet. Dendril is basically used to solve or to suggest the more or infective molecular organic components in the organic chemistry, and it is used to detect all those irregular components with the help of mass spectra, where PixLS is the expert system that is used to suggest the lung cancers in anybody's body. In this, the the upper body's scanning is being done, and the scan is in the form of the shadow, and after scanning those shadow, the harmful areas are detected in this export system. Predators basically used to detect the cancer in the very early stages. So these are few of the examples that are used nowadays. Sixth is the robotics. Robotics branch is the branch of engineering that is devoted to the creation and training of robots. It works with a wide range of fields such as mechanical and electronic engineering, cybernetics, and bionics, and AI also. AI is used in the robotics through with the help of machine learning. It enables the robots to learn and perform specific tasks through observing or mimicking some kind of human actions. It gives the robot a computer vision that enables them to navigate or detect and determine their reactions accordingly. So in the field of AI, the robotics aim to create an intelligent environment in the robotics industries for the better automation. In this, it uses the computer vision techniques to perform some kind of intelligent programming. It is used for performing some kind of reinforced learning to teach the robot to behave like human and to make human like decisions and execute the task in the dynamic conditions. So in this way, this is a very fruitful and very effective application of AI, that is one of the emerging field in AI also. Next is the natural language processing. So natural language processing is basically a technology which involves the converting of spoken or written human languages in the form which can be processed by the computers and vice versa. Basically, NLP is what? NLP is the processing of the languages. As I am a human and I am interacting to you, so I am able to interact you with any of the languages like Hindi, English, or whatsoever in which I am comfortable with. And you as a human, if you are comfortable with my language, you are easily able to understand that language very frequently. But if I use another language which is not of your domain, so it will be very difficult for you to understand that language. For that thing, you need some kind of translations, or you need kind of understanding to understand that process what I am going to say to you. So natural language processing is basically the processing of language from one person to another. When I am a human and I am converting or conversing with a human, then that is okay. But here this NLP is talking about when a machine is interacting with a machine, or a human is interacting with a machine. In that case, that understanding and that translation required some kind of efforts into it. So before going to step up and to know more about NLP, first I'm going to tell you various applications of NLP. So first application is the voice recognition system, that is nothing else but the Siri, Google Assistant, and Alexa that I'm using nowadays. That is basically translates my speech into input for any kind of word processors and other applications. This is one of the emerging field, and this is one of the emerging application of NLP technique that understand and respond according to the user request as well. Second is the text to speech synthesizers. Basically, that is the when Microsoft Edge browsers read document for a person, that is being used to read text aloud for the user as the person is hearing impaired or something else like that way. So this is one of the application of NLP. Text summarization tool, basically, which I use to extract something or to summarize something out of any particular information. In that case, creating short and accurate information summary of the text document is being done here. In that case, both extractive as well as abstractive techniques are used. Extractive techniques is the one in which I extract the critical information from the original text, and I include that critical information in and include that thing into the summary of that paragraph. And abstracted information, in which I can able to introduce some kind of new sentences to the particular information that I have already derived. In that case, these are the both techniques that are used in the text summarization. So there are also various tools related to this. The next is the grammar and the style checkers. The most common example is the Grammarly and the Ginger used in documenting a system, where Grammarly is basically the system that is used to detect the spellings in the document, and Ginger is basically the combination of both the spellings checker and the dictionary as well. So these are the basically grammar and the style checkers. Next application is the machine translation, in which very common and very popular example of NLP that allows to translate the text of one language into another automatically. So the common example is the Google Translator here. So these are basically the very emerging fields of NLP and the common applications, and there are also various other applications also that is used in the NLP. So after listening all these applications, what this NLP actually is, I'm going to discuss that thing. So basically AI helps the computer to understand the natural language like English, Hindi or Nepali, etc, etc. So in that case we need to communicate with the computer like human being. So basically, as I've told you, that when I am talking to a human, so human can easily understand the language of other human and also able to sense the feeling and the motive and the aim of speaking to the person as well. But when I am talking to a machine, because that machine is not having that kind of senses or some kind of intuitions into it, so it will be very difficult for a machine to understand that thing. So NLP is basically inserting that input in some kind of machine. So after that input is given into the machine, the phase arises is the natural language understanding. So that means the understanding of that particular language is being done. That means in the form of what the person is saying, how the person is saying, what is the feeling behind that, what is the aim of that, and what the person wants to get as an output after saying that particular sentence into it. So understanding is all about the division of that particular sentences into the last level, that is up to the phonics of the sentence. So if, for example, if I say the tank is full of water, in that case, if I am saying this as a sentence, in that case I am able to understand, I as a human can easily relate all the things, that the tank which I am talking about is about the water tank, and this sentence is depicting that the water tank is full of water. As a human, I can easily understand the thing. But when it comes up to a machine, so the first phrase of the NLP is the natural language understanding, in which the first phase says the lexical division of this thing. The first phase is the lexical division of the thing. Lexical division or lexical phase says the division of the sentences into tokens. So basically, this is one token, this being a second token, this being third token, fourth, fifth and sixth token as well. So all these tokens will be taken individually and their meaning will be individually taken. So that means when this tank as a token is being treated, this tank is being confused as a water tank or a military tank in that case. So this is the first phase, how the system is gonna decide or to understand what is the meaning of the sentences. So the first stage is the lexical phase. Then the second phase is the finding the missing gaps between the sentences. The third is the finding the meanings between the sentences, and last phase says the finally assuming or asserting or deciding what is the meaning behind the sentences. So after going through all these phases, the language is being understood or the sentence is being understandable. So this phase is not simple as it seems to be. As I've told you, the major issues involved in this understanding of language is the lexical errors. The first phase error is the lexical errors, as the sentence is being deployed or broken into various kind of tokens. So every word have variety of meanings into it. So as I have told you that I am talking about tank, so this tank has two meanings, water tank or a military tank. So it is all about, after analyzing all the sentences or after reading all the sentences here, then I can able to assure you then make a decision that this tank which I am talking about is the water tank here. So lexical errors are basically those pattern based or phonics based components or word that makes various meaning to our sentences. So this is the first error that occurs in the NLU process. The second is the syntactic error. Syntactic error is basically the missing gaps or the punctuation marks or some kind of missing words or meaning between them. Then is the semantic error. Semantic error is basically the missing of the meaning behind the words. So basically it try to match or it try to connect the word one to each other. That means if I am talking about tokens like tank and water, and here no other helping verb is given, so in that case of semantic error, if these two tokens are there in a sentence and two tokens are being derived, so in that case semantic error try to breach this distance and this gap between them, and they try to relate that this tank is related to some kind of water. So it is full assured that this is a water tank which I am talking about, because as here the sentence is having some kind of token that is water, if water is there. And if there is no water, if a token like military or army is there, then this tank will be associated in the form of any kind of military tank. So in this way, this semantic error in the NLU is try to breach that gap out of it. Then next is the pragmatic error. Pragmatic error is the area in which the linguistics examines the context of the linguistic utterance. That means if I'm saying, could you please pass me a salt? Could you please pass me the salt? In the general context or as a human context, I can easily able to understand that this is normally a request given by person to any other person, and this question is being answered in the form of yes or no. But when I am talking about NLP, this will be very difficult for the machine to understand this, or this kind of error means that when this request is being misunderstood in the form of any excuse. So this is the problem. So finally, after this phase, after handling all these phases and all these errors, natural language is being generated in the form of some kind of expert system or expert advice, or you can say the understanding of all this is being introduced in the form of some accurate or precise information that is being derived as a form of some corpus, and finally that output is given. That means if I'm saying anything to the Google map that I want to visit some foodie places, so it will give me variety of options of various nearby foodie places to me. It will not find me the clothing spaces places for me. So that means it will intelligently categorize my problem and understand my problem, finally generate a very precise and accurate answer that is very dynamically and very structured in the form of very structured form. So this is one of the leading application of AI. Next is the machine translation. This is nothing else as the I have already told you that Google translation is the common example to this. That means machine translate from one language to another. Then the next is the computer vision. That is being the field of AI in which computer trains or captures and interpret the information from the images and video data. The most common example is like the unlocking of our smartphone that recognizes our face. And other examples of computer applications is basically the OCR using the computer vision, defeat detection system, crop monitoring, road control monitoring, some kind of X-ray analysis, MRIs, plant disease detection, traffic flow analysis. These are very common examples of computer vision. The next is the e-commerce. E-commerce is the very bustling segment and very emerging segment of AI, application of AI, in which the retail industry uses this as a very important component. In this, advanced technologies like AI or machine learning is being introduced into this, and the company uses those AI as a chatbot, as an assistant, or some smart logistics using the algorithm to predict and analyze the customer behavior. Basically, the customer recommendation system is being followed over here. So the ultimate aim is to reduce the shipping cost, as well as it also demands, or it also helps the company in demanding the forecasting of the products, product research rankings, and also able to product and deals recommendation, merchandising their placements, fraud detections, and much more than that. So these are basically the emerging application that I'm covering here. So all these applications are being finally synthesized, or you can say integrated as per this diagram. So this is all about the applications of AI. So I hope that you have liked the video. So thank you so much for listening.